Okay, scholars, now we're going to be working with the law of cosines. Now, the law of sines works great if you see angle, side, angle, 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 side, or side, side, angle. However, that doesn't work when you know three sides or you have SAS. We have to be able to work out solving for the missing ones. So we also have what's called the law of cosines. Now, the reason why the law of cosines is so big is just saying that every angle is opposite its opposite side, and so every angle has a different opposite side. So when we do this one, the law of cosines is a squared equals b squared plus c squared minus 2 times b times c times the cosine of angle A. Notice the two that are opposite, the A and the A. Now, the same thing just means, like, if I choose B here, I have to use the cosine of this angle B. So this time, the two other sides end up being A and C times the cosine of angle B. And if I choose C here, it's opposite the angle C. So notice they just change based off of what side you're working with. Now, here's the thing. It doesn't matter to me which one of these you write. The main thing is that I ask you to use this first one because all I'm going to be doing is matching side with angle. And so the other sides and stuff will come into play. You'll see what I mean while we're working on this together. However, when do I use this? Well, this is important to know because you have to know when to use the law of sines or the law of cosines. Well, you only use law of cosines in two cases, sine, angle, side, or side, side, side. And it's actually easier to memorize when to use the law of cosines than it is the law of sines. So that means you're going to sit there, and I'm not going to tell you which one to use, except for like practicing today. I'm going to ask you to look at it and say, oh, that's side, angle, side. Oh, therefore I use the law of sines. Or that's angle, sine, angle. Well, that's the law, side, angle, side, law of cosines. Or angle, angle, side, law of sines. You have to choose that on the test, but I will give you the formulas. So let's apply the law of cosines, because once you see how it works, it's not too bad. Here we have side, angle, side, correct? Where the angle is included between the two sides. Now I'm asking to solve for the length of segment XZ. So I'm going to call that side A. If that's the case, we're going to let angle Y be not the case. It should be the angle Y is the one that's opposite of that. So that's going to be the capital A that I use in my formula. So the formula we're going to use is A squared equals B squared plus C squared minus 2 times B times C times the cosine of angle A. So when I do this, we just plug it in. Now here's all we have to do. XZ, well, that's A. So we have A squared equals, and the other two sides, it doesn't matter which one's B or C, is going to be 35 squared plus 30 squared minus 2 times 35 times 30 times the cosine of 110 degrees. Now, the one thing that I want you guys to get in the habit is to simplify before you put a lot into your calculator all at once, because I get a little concerned when it's really large and huge that we can lose track of ourselves. So the first thing I'm going to do is have you simplify. Use your order of operations, square these, and add them together. So you should get 2,125 minus 2 times 35 times 30 should be 2,100 times the cosine of 110 degrees. What that does is it leaves us from having a lot of extra stuff where we can lose track of signs and things. So what I do next is I need to take the square root of both sides. This is what I'd love to see you plug into your calculator. When you do that, what would you get to the nearest tenth? Because I asked for the sides to the nearest tenth and angles to the nearest degree. What did you get for that side? 53.3. And when you do that, if you notice, that kind of is reasonable. This is 110 degrees. The other two are acute angles. They should be larger than the other two. So it's kind of cool how that works out. All right, let's flip it over and do a couple other ones here. This time, I look at this and I say, what do I have? I have side, 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 no angles. Therefore, again, I have to use the law of cosines. So I'm going to let angle T, which I'm looking for its measure, that's going to be X degrees. Now, how do I know to set up the equation? Well, let's write it down first. I'm going to put it up a little bit higher so we have room to do all the other ones. We got A squared equals B squared plus C squared minus 2BC times the cosine of A. If I'm looking for the angle, this becomes the capital A. That becomes my angle I'm looking for, which means opposite of that, lowercase a is 7. So now I plug in, and again, B and C are 13, 11. It doesn't matter which one's which. So when you plug it in, you're going to go 7 squared equals 13 squared plus 11 squared minus 2 times 13 times 11 times the cosine. And let's just call it x degrees here, since that's what we put the angle in, x degrees. Again, simplify like we did earlier. We get 49, and 13 squared plus 11 squared is 290, minus 2 times 13 times 11, oh, that gives us 286. I'm sure you all have that memorized and do that off the top of your head, times the cosine of x degrees. Now, the number one error I've ever seen students make, and this is just a silly algebraic error, is I see people trying to combine these two. And order of operations says you can't do that. So instead, I'm going to subtract 290 from both sides. So I get a negative 241 is equal to a negative 286 times the cosine of x degrees. Well, I want to get the x by itself, so I'm going to go ahead, divide by negative 286. So I get a positive 241 over positive 286 equals the cosine of x degrees. Well, now what am I going to do? Well, I'm now going to take the inverse cosine because I'm looking for the angle. So I go the inverse cosine of 241 over 286 equals x degrees, which means if I put this to the nearest degree and I punch that into my calculator, I should get the fact that the measure of angle T is approximately, I should say right here, equals going to be 33 degrees. I think it's 32.6 something if you do it right. Now let's do the next couple ones. Again, practicing what we know. Here I have side, angle, side. Therefore, I know it's a law of cosines. I'm looking for the missing side. So it's like our first one, part A. So I still start with, oops, there should be an equal sign there, forgive me. Our law of cosines written down. And I'm going to plug in. Now, if I'm looking for this side, that's A in my brain, okay? And then this, I know, has to be the one that goes in for A in the thing. So instead, I'm going to put an X this time. Now, you can put an A, you can put a B, I don't care. Just put a value in. So I'm going to go X squared is equal to 18 squared plus 16 squared minus 2 times 18 times 16 times the cosine of 21 degrees. Now again, we're going to add and combine our like things. So we get this to be 580 minus 576 times the cosine of 21 degrees. Now, what do I have to do to get x by itself? Take the square root of both sides. When you do that, and you punch it into your calculator, you should get that x is approximately 6.5. Now remember, x is also the length of segment DE, so you're going to see me write it kind of like this time, just so we know exactly what we were looking for. So the length of segment DE is 6.5. All right, let's finish this one, and we're going to be done. This time I have side, side, side. So again, I'm using the law of cosines. I'm looking for the measure of angle K. So that means these have to be my side and angle that are opposite. So when I write my cosine formula down, now I had someone ask in class, Mrs. Gregerson, why don't I use the B squared or the C squared one? It's doing the same thing. It just means every angle is opposite another side. So I can just use this one to make it really easy on myself. Now here's something you need to realize. On the test, I will give you the formulas for the law of sines and the law of cosines. What I won't do is tell you which one to use. That's going to be up to you to memorize that. So then I'm going to go ahead and plug in what I know. So I'm going to go here. A, which is going to be the one opposite, so this will be my capital A, right? Is going to be 8 squared equals 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of x degrees. So I get 64 equals, I think we get 325 here, minus 300 times the cosine of x degrees. And I think even the other day I just said cosine of angle K. So whatever works for you to substitute it in. I'm going to subtract 325 for both sides, so I get a negative 261 equals a negative 300 times the cosine of x degrees. Now another error besides people accidentally trying to combine those is people drop this negative for some reason, and one of my biggest pet peeves is don't drop the negative. And so I go ahead and I divide by negative 300, so I get 261 over 300 equals the cosine of x degrees. Now I'm looking for the angle. We got to take the inverse cosine of my ratio equals my angle. What do we get here? I know the measure of angle K, which equals x degrees here, is approximately to the nearest degree is going to be 30 degrees. And I know it's not quite 30 degrees, but it gives us a good approximate of what we have. Hopefully that helps you see how to do these. Guys, I know you can do these. These just take time and a lot of detail, but you guys are very capable of doing a great job on these.